The idea of intrinsic and extrinsic values is often obscured by inaccessible language, so let's present this in a more accessible way. First, think of yourself. You have a name and a core of your being. You can call this a soul or character. We're not trying to be too philosophical here, but barring any legal name changes, your name belongs to you for the entirety of your life. Anything that belongs to you as a person and is unchanging can be thought of as part of your intrinsic or interior state. You will hear this referred to as an object's context in programming scenarios. Conversely, your age, height, weight, and various other properties will change over the course of your life, as well as how you interact with the world around you. This can be categorized as your extrinsic or exterior state. These properties do belong to you as a person, but they change as you go through your life and are separate from your internal context. Knowing what we know now, let's hop back into Visual Studio and take a crack at updating our concrete classes with their intrinsic and extrinsic state. First thing we'll do is add in private variables for our name property, since we don't want these to be modifiable after they're initially set. So it's private string underscore name, and our public getter will always return that value. We're also going to add in a private IEnumerable list of ingredients. This is going to be of type string, and we'll call this underscore ingredients. To keep things synced up, let's do the same thing in our banana smoothie. And we'll save. Next, we need to set each of our classes' intrinsic values, which you can do inline with the variable declaration or in the class constructor. It's up to you. I like the constructor for clarity, but it's dealer's choice. For the espresso, let's say public espresso, and we'll set the name to espresso string and ingredients to a new list of strings. And let's just initialize that right now. We'll say it has coffee beans and hot water. It's pretty simple. Now let's go into our banana smoothie and we'll do the same thing. We'll set our name value to banana smoothie. And we'll set our ingredients list to a new list of strings. And for this, we'll just say there's banana in it, whole milk, and for a little bit of extra taste, vanilla extract. Why not? Now all that's really left is to update our serving string in both of our classes to make use of the intrinsic and intrinsic state values that we now have. So we'll start off and we'll print out the size, the name, and we'll just print out the ingredients as well. And we'll just use string join for this. Makes things a little bit easier. And we will be joining, let's see, a comma and a space with our ingredients list. Now let's actually take this, copy it, and put it down in our banana smoothie as well. And don't forget to save. Now you might be tempted to store the intrinsic size value in an effort to keep the object's data complete. However, this violates the principle of having shareable intrinsic state. The whole point of the flyweight pattern is to provide shareable templates of objects to conserve memory. If you updated a shareable object with its intrinsic state, that would trickle through every concrete class reference that you've created, which is definitely not what you want. For example, if we continually saved an espresso's size when serving, all of our other espressos would be updated, even if we originally served them in a different size. You'll find a lot of flyweight examples out in the wild make this crucial mistake. Now, if you do find yourself in a situation where you need to store extrinsic state, a common practice is to use instances of a context class. An array of context objects could then be stored in the client code, mapped to the flyweight being used, and passed into any flyweight's extrinsic state method. This might rub you the wrong way, as this would create more objects for the application to store, defeating the purpose of the pattern. But context objects would take up significantly less memory than a host of objects being created without the flyweight pattern.